You're listening to Brain Lenses. I'm Colin Wright. Schizophrenia is an at times debilitating mental disorder that's thought to afflict somewhere between 0.3 and 0.7% of the total human population at some point in their lives, though that number is potentially a significant undercount, as many people with this and similar disorders are assumed to be undiagnosed. Many mental disorders go undiagnosed because they can be tricky to detect, or in some cases, as is true of schizophrenia, because there's no objective diagnostic test to delineate someone who is schizophrenic from someone who has similar symptoms but for different reasons. There's a lot of opportunity for misattribution and overlaps in this facet of mental disorder diagnosis too, as schizophrenia can cause sufferers to experience vivid hallucinations and delusions, disordered thinking, a numbing or reduction of expressed and experienced emotions, reduced motivation, all sorts of motor and cognitive impairments, and a difficulty engaging in human behaviors like forming relationships with other people. Considering how life-altering, usually not for the better, a condition like schizophrenia can be, it is not unfair to ask how such a thing could make it through the filter of evolution, which in theory at least should weed these sorts of hobbling traits out of the gene pool over time, because they hinder the survival and procreationary drive in those suffering from them. The same could be said of countless other conditions as well, ranging from autoimmune diseases like type 1 diabetes to genetic disorders like sickle cell disease. The question of how such things persist in the gene pool despite being so biologically obstructive is not new, and such traits are often called evolutionary paradoxes because of how unlikely they seem through the lens of survival of the most adaptive style models. There's another concept, the cliff edge model, that helps explain some of these paradoxes. Consider that human childbirth is almost bizarrely difficult compared to childbirth for other primates because a human baby's head is so large in respect to its mother's pelvis. This fetopelvic disproportion would seem to be another evolutionary paradox, as it makes birth-related issues a lot more common. But research has shown that this disproportion is actually the result of a cliff edge fitness function that optimizes for a mean outcome, births generally going okay, by aggregating baby head sizes and women's pelvic sizes around that outcome, while also taking other fitness-related traits into account. In practice, this means if you have the target area of the middle of a scatter plot graph, the perfect combination of head and pelvic sizes in the middle, you will tend to have pelvises that are much larger than a baby's head, and babies' heads that are too large for their mother's pelvis, off to either side of that central ideal. If the baby's head is way smaller than the pelvis, that is a missed opportunity in terms of the baby developing before being born, which in this context is an evolutionary missed opportunity. If the baby's head is way smaller than the pelvis, that is a missed opportunity in terms of the baby developing before being born. And if the pelvis is too small for the baby's head, that puts both mother and child at risk, which is also an evolutionary missed opportunity. Many of the not quite ideal dots on the chart are so close to hitting that optimal proportion, but not quite there. The increasing use of cesarean section births has shifted the success rate for that latter mismatch too, and this is expected to nudge the mean, successful, evolutionarily optimized range toward that outcome, with more people fitting into the everyone surviving category, but that seeming paradox becoming more apparent over time as more baby heads are too large for their mother's pelvis. Being just a tiny bit offset from the ideal evolutionary equilibrium can lead to horrible consequences then, despite those who are thus afflicted having basically the same traits as those who fall into the most evolutionarily ideal category, with just a tiny shift in one direction or the other. This is where the cliff edge moniker comes from. The same general principle seems to apply with other evolutionary paradoxes like schizophrenia. Recent research indicates that this disorder is a slightly off-ideal manifestation of several traits that, if they were just a little closer to that evolutionary balance point, would grant their bearer all sorts of advantages, cognitive, linguistic, and/or social. But because they are combined in a non-ideal way, or because they're a little too intense, or showed up in off-balance proportions, they instead do the opposite. Just like having a child with a larger head can be beneficial, but not if it's too big for the mother's pelvis. This model helps explain seeming evolutionary paradoxes, and while not a hard-set rule, it does point at some interesting avenues of exploration, especially in terms of how such traits will change in the future due to procedures like cesarean sections and schizophrenia drug cocktails that we use to ameliorate issues caused by these disorders. I'm able to present Brain Lenses in both its written and audio formats ad-free, because of support from listeners like you. If you're enjoying what I'm doing here, consider becoming a paid supporter for the cost of a cup of coffee each month at brainlenses.com.